with that
Oh,
over
yeah.
there
Okay.
because we're sharing the screen.
I can just minimize that.
Yeah, cool.
Yep. Cool. Okay, so just starting off with the announcing the general availability of the enhanced row-level security editor in Power BI Desktop. That's been coming for a while to be used. I'm just trying to find. Oh, there we go. Okay. Then now the option for the DAX query view is available in Live Connect mode. Previously, this was only done in Power BI Desktop. You now can do this when your model is live connected to a semantic model in the Power BI service. There's also now another update to the DAX query view where you can add or update multiple measures at once. Previously, you could only do one at a time. So this just helps do that a lot quicker. Then moving on to updates in the service related to Power BI. The storytelling in Power BI has got a new export dialog, just making it easier to do those exports with links and what you want to actually export. There's also been an update to the Power BI report format, the PBIR. There's PBIP, PBIR, etc. So the previous limitations that they did have around can't be exported or included in subscriptions, mobile layouts, and couldn't be utilized in Power BI Embedded, that has all been removed. So meaning, when you upload this format into the Power BI service, it now will have a lot of more functionality. As always, there's a gateway update for the July release to coincide with the July release of Power BI Desktop. There is the Power BI report server key now is available when you have your Fabric capacities on the top right. You can go and get that. So that wasn't there previously. Also, once again, Microsoft was named a leader in the Gartner Magic Quadrant for analytics and BI platforms. It's been there for a while, but obviously it's not something that you just automatically get. So it's good to see that the investments are showing through with Gartner. Then some of the updates with regards to Fabric. It is now SOC certified, which is one of the things they've been just catching up and adding all these additional certifications with regards to Fabric. There's also an option now to easily move your data to two different workspaces, two different lakehouses as a destination. Previously, you couldn't do this, but now it is available. There's also been updates to the semantic link. So the semantic link, for those people who don't know, that is used in Fabric notebooks. And what that allows you is to access things in the semantic model. So the link is a way where you can basically, for instance, run DAX queries, update partitions, etc. So the updates with regards to this one is it's in pre-installed with the default runtime, so you don't have to go and actually install this when you're using a notebook. And in the change logs, you can see what has changed, and they're constantly updating this. It's not every month. Sometimes they're actually updating it as weekly, etc. Next, there's the Fabric API for the GraphQL, which basically GraphQL is a way for you to take your data and then expose it via an API that people can query, almost like an API in there. And it's just announcing the pricing for that, where it will be consuming capacity units. And when you go into the metrics app, you can actually see what it's consuming and what the cost will be. Then now also is the updates in terms of source control. Not only do you have Azure DevOps, you now can integrate with GitHub. So you have both of those providers, which I know a lot of customers were in one or the other, but GitHub, is used quite a lot through organizations. Also, they've improved the fast copy with on-premise data gateway support for Dataflow Gen 2. So what that long story means is pretty much if you're getting data through the gateway, they've improved the fast copy performance, where they say between 4 and 8 times faster to copy that data in. So not only is the data copying faster, it's also going to consume less Fabric capacity. Then there's the general availability of time travel for 30 days when you're using the Fabric warehouse. So what that means is the time travel, you can go backwards and forwards in time with regards to using the data in the Fabric capacity. And that's it. So thank you. Thanks to our sponsors again. And I'll hand it back to Craig.
Thanks, Gilbert. Awesome.
So for those that are online, Gilbert and myself and others will be monitoring the chat. So please feel free to put your questions in the chat. And if we get a logical pause moment, I'll interrupt Phil to ask those questions. Unfortunately, due to the audio being on the laptop, Phil, I am going to ask you to repeat any questions.
Yeah, absolutely. Yep.
Yeah. Especially questions that are asked in the audience for those who are online. Appreciate that. Yeah, so with that, I will introduce our main speaker for the night. So Phil Seamark, we're very lucky to have Phil over from New Zealand. Phil is a member of the Microsoft Fabric CAT team. And if you're not aware what that is basically it's a team of highly skilled, very knowledgeable people about Fabric and Power BI. And CAT stands for Customer Advisory Team. So basically, their job is to ensure that the biggest, most complicated Fabric and Power BI implementations in the world are running smoothly. So with that, I'll hand over to Phil, who's going to be talking to us about DAX Fusion.
That's right.
Did I get that right?
Yep. Okay. Absolutely. So thank you. All right. All right. So hopefully you can hear me okay. And if I don't, raise your hand if you can't, and I'll speak louder. I did have a head cold last week. Don't worry, I'm good. F5. Okay, so optimizing DAX Fusion. So as Craig said, my name is Phil Seamark. I work for Microsoft on a team called CAT, Fabric Customer Advisory Team, and we do work with the world's largest enterprise customers who use our products. And inevitably, those customers have got a large number of users, massive amounts of data, and they try to, well, their goal is to get Power BI to create reports that run very quickly and keep all their users happy. Inevitably, when you have got a large amount of data and a lot of users hitting your reports on a Monday morning, there can be the occasion when things can slow down. So they call us, we get involved, we look for the reasons why that might be happening. We help the customer, we solve the problem. Perhaps we fix the product, we put something in the product that's going to make things better. But also, I come to events like this where I can share the learnings that I got with people like yourself. Now, tonight's topic's going to be quite advanced. It's on DAX, and hopefully, if you're using Power BI, you are writing some DAX. Now, good DAX is not very much DAX. What I tend to find is the more DAX you write, the slower it goes because it's getting too complicated. So generally speaking, the less DAX is the better. It probably means you've got a good, clean model and you understand what you're actually trying to solve and you're trying to do things at the right place. There are appropriate uses for DAX, and there are also things that you probably should be doing upstream. Now, tonight's topic is going to be an advanced topic on DAX. Now, I'm not expecting you to remember every single syntax. Potentially, the main takeaway at the end is going to just be the opportunity to see what a more advanced diagnostic, let's take a bad report, and I'll show you what the layers look like to make what we can do to turn that into a faster report. And the particular topic we're going to be focusing on tonight is a sub-feature of DAX, which is DAX Fusion. So this is not going to be something you apply in every single report you work with. It's not going to be something you apply in every DAX calculation. Typically what I find is when a customer contacts me and says, hey, I've got this really slow running report, I'll say, it's not a matrix visual, is it? They're like, how did you know? Say, okay, in that matrix visual, how many measures have you loaded onto it and how many rows has it got? So how many cells are all trying to calculate when you load the page? Like, oh yeah, no, there's a lot. We need to put this all on the one page. And it's taking 60 seconds to run or a minute to 90 seconds to run. So, okay, maybe let's have a look at the more advanced technique to see if there's a way that we can get that down to, you know, just a second or two to load. So, so what are we going to talk about tonight? What actually is Fusion? There's a couple of varieties of Fusion, and I've got some demos to show what that looks like. Hopefully you can see the screen okay. It has been recorded, so you can get the recording later from Craig if there is something you want to go back and look in at a little bit more detail. We are going to do an optimization exercise. So this is the classic, someone taps me on the shoulder and says, hey, Phil, I've got this matrix report that's really important. The CEO is going to look at it. Everyone looks at it on Monday morning, but it's running slowly. can you help me make it faster? It's like, yep, sure. And we're going to go through and start with a bad report and hopefully end up with a good report. And then we'll summarize at the end some of the tips and tricks we've learnt along the way. So Fusion, there's a couple of different types of Fusion. There's regular Fusion, which has been around for a while, and there's horizontal Fusion. And let's actually have a look at the difference between regular and horizontal Fusion with my favorite DAX authoring tool, DAX Studio. And I think it's going to be, bear with me. All right. Okay. So I've got a model here that's a, I'll show you the model actually. It's using Contoso data. I could be using AdventureWorks data. I have created a clean model. This is the before model. So I have a fact table in the center. Oh, wrong screen, sorry. Okay, let's just zoom out a little bit. Okay, we don't necessarily need to read the text, but I have a fact table in the center at the bottom, and that fact table is reading data from a direct query source. Now, Fusion, it doesn't matter whether you're using direct query or import or direct lake, the fundamentals are the same. I'm deliberately using SQL as a source in this case, so it's really easy to spot when we're having a look at some of the trace data. But we're going to be running some metrics over this table in the center, and we slice and dice by some dimension tables around the outside that are not unusual to what you might see in any organization. There's a date dimension, product, geography, and geography is chunked up by store. So that's what the model looks like. So what I'm going to do is grab some DAX and put it into DAX Studio and connect to a model. So hopefully you can see this all right, and I'll zoom in. I have a 4-line query here at the top that when I run, it's going to give me 2 columns. It's going to be a column at line 6 grouped by brand name. So every single brand name I've got in my dimension table, and then it's just going to do sum of sales for those brand names. Nothing too complicated. And if I expand my ribbon, and maybe if I connect to my model and run it, okay, I get some results. Should get some results. Here we go. That's what I'm expecting. But DAX Studio's got this feature that I can turn on called server timings that allows me to not only run my query, but it's going to tell me all the little sub-steps that take place behind the scenes to make that query produce the correct result. So I'm going to rerun my query again, and I clear the cache every single time. So we're going to see what took place. What did the engine do? Now the engine did one storage engine scan, one trip to the data source. We can see that one item here, and when we click on that one item, we actually get a SQL-like view of what it's doing. So hopefully, if some of you have written some SQL in the past, over here we can sort of see a summarization about what that storage engine activity did. Now, what does this mean? So the analogy I like to use when I think or talk about the storage engine is baking a cake. So if the goal is to produce a cake, what you need is a recipe, and the recipe is going to be instructions about what you need to do. Now, my kitchen has no ingredients, so I need to go to the store. Now, ideally, what I want to do is make one trip to the store, get in my car, go down 10 minutes, go to the store, get all the ingredients I need. No more. I don't want to buy every single ingredient that's on the shelf. I just want to get just the right ingredients I need to bake my cake. And then I want to come back and then obviously put it together. And in this case, that's what's happened here. I've made one trip to the data, which is my trip to the store. And in that, I've said, go and give me every single brand name, some sales amount. There's a join going on. This is nice and efficient. Okay, so that's just a little bit of background about a simple DAX query. Now what I'm going to do is, instead of grouping by brand name and sum sales, my second query is going to do a sum over the quantity column. Now my fact table has got a sales amount column and it's got a quantity column. So when I run this query, I actually am going to get exactly the same kind of result. I'll get different numbers. I'll get 2 columns in my results, as expected, but the server timings again is going to tell me down here that I only needed one trip to the store, and my one trip to the store did this work here. Okay, and I'm going to focus on in the select part of the query. Here's where it actually performed the aggregate sum over the quantity column. Now, if you roll back the years, if we decided to write a third query that combined the, I wanted to do a sum over sales and a sum over quantity, what would happen is the engine would make 2 storage engine scans. It would make 2 trips to the store. It would go and get the milk. When it would come back, it would go and get the flour, if that was all it needed for whatever it was making. But what we want to see happen is fusion to kick in, which it does here. And this is regular fusion, not horizontal fusion. And regular fusion is saying, okay, I only needed one trip to the store, the storage engine. And when we look at this, it has sensibly recognized that both of my requirements share the same from and group by and where clause. So I can fuse them together. And I have got in here a select statement that does both the sum of sales quantity and sum of sales amount in the same trip. So it's been smart. This is good. This is what we want. We don't want to see 2 storage engine scans because they might happen. They might wait. There's only one car. So one has to go bring it, come back, and then go back again. They can't do it in parallel, for example. We have got parallelization working, but that's what we're really trying to avoid. So that's regular fusion, and that's how you spot it. And it happens automatically. There's not really much you can do apart from just make sure that the filter criteria, the froms and the where clauses that are likely to be needed match so that they can be fused. Because I'll show you, now we're going to start talking about horizontal fusion. So I'm going to try and give you a slightly different version of the query. So we're going to group by brand name again. This time we want to calculate sales, but only show me sales where the brand are for products that were red. And in my other column, for some strange reason, I want to sum the quantity column, but only for products that are colored blue. Now this is going to work. This is going to now give me a 3-column result set. The first column will be every unique brand name. The second column is the sales for red products. The third column is the quantity of blues. Now, the important thing I want to focus on is the query plan. What does the server timings look like? And we were smart enough to optimize it to a single trip. So we've got one storage engine query down here. Hopefully I'm not covering that. And when we click on it, again, for those that are used to reading SQL, I'll bring this over a bit. Maybe I'll drop this back, minimize, drag that up. Okay, so the key feature here is in the where clause, we've been smart enough to say, rather than do a trip to say, go get the sales for red and a second trip for the quantity for blue or whatever way it was, we are doing regular fusion up here, but we're getting a result set that has both, and then we're post-processing it. We're figuring out back in the kitchen, in the formula engine, how to actually take that result set and finish off to arrive at the correct result. So if I take this query and jump over to my SQL Server Management Studio and paste it in, we can kind of see what the intermediary table looks like that came back to Power BI. So we have 19 rows. We've got a bunch of rows that are blue. So one of the measures is going to say, what I care about is for the blue rows, these numbers, but the formula engine is going to say for the red rows, I want those numbers, and so on and so on and so on. So that's what's going to happen back in the formula engine. And the good thing is, because there are only 19 rows, it doesn't have to process over a lot of data. My actual fact table could have many millions or even billions of rows of data. But if I only have 20 brand names, it's the size of that intermediary table that I want to make sure has enough information in that I can post-process. So regular fusion, so that's horizontal fusion. That's in the where clause, what's going on with the inside of things. But unfortunately, the horizontal fusion has a little bit of a gap. And the gap that is when you might write a query that looks like this, the next query down. So I want to, I'm not changing my sales. So I'm still want to have a 3-column table that says, show me the sum of sales for red products. And let's go quantity. Okay. For products that are blue, but I'm going to introduce an additional criteria just here on this line 41. And what effect is that going to have on the ability to fuse these together? If I run the query, I'm going to get the right result. So I get the 3 columns, the brand, the red and the blue quantity, I've called it that. But the server timings now, I'm no longer getting a single storage engine event. We'll see over here, and now I've actually got 2 rows, a SQL here and a SQL here. Let's see what each one actually does. The top one is just focusing on the sum of sales, but for color is red. Okay, that's good. That gives me an intermediary table that helps me figure out one column. But this other storage engine, another trip to the store, is now saying I'm going to go get quantity data, but where the color is blue and the class is regular. Now, why have we got 2 instead of 1 now? And that's because the where clause has got a different profile. It's got a different fingerprint. So we can't fuse them together. So ideally what we want to be able to do is, if we want to fuse these together, we need to kind of trick the engine into saying, for this line here, this line 40, why don't you, for red products, also go get data for every class name? Even though I know I'm not going to use it, just go and get data for every class name. And that way we can fuse the 2 queries together. And it's going to give me an intermediary table back with more information that I need, but then I can post-process it and filter it. And honestly, that is going to make a big difference when things like high concurrency kick in on a very busy report. So how do I do that in DAX? How do I actually rewrite my DAX to allow horizontal fusion to kick in? And that's my last little DAX query here. And I might have to zoom back a little bit. There's a bit going on here. So I've written the query a little bit more like how Power BI Desktop would write it. So I've got it grouped by brand name. And I haven't just done red and blue sales. I've also introduced a third one here. So my red is on its own. My blue is sales, but where class name is regular. And my yellow is quantity, where class name is deluxe. And it's calling a measure called sales and calling a measure called quantity. And I've written those measures just up here. And normally, these would be 1-line DAX measures, just to be sum of sales or sum of quantity. But for horizontal fusion to kick in, we actually have to wrap it in this iterator pattern. And that's the key. It's quite an advanced approach. That's how we can influence the shape of the intermediary table that comes back. So what are we doing here? What we're saying is, I want to create an intermediary table that is grouped by color name and class name. And give me every single permutation of color and class, the whole lot. So if there are 10 colors and 10 classes, small, medium, large, extra, extra large, etc., I want a permutation intermediary table with 100 rows. And in that 100-row table, make sure you put in a column that does sales of some amount for each one of those permutations. But then what I'm going to do is, depending on my visual, what row or column I'm in, like if I happen to be in red and extra large, go and find that cell from this intermediary table and use that when you're rendering the visual. But I need to shape the intermediary table. So this is what it looks like for my sales measure. What I have immediately underneath it is exactly the same pattern. But instead of sales, I'm doing quantity. Everything else is identical, but I've replaced the calculation here to say use this other column. But I'm defining the pattern. I'm saying, when you go and perform a sum over that, what I want you to do is stick it in an intermediary table that is set at the grain of color name and class name. So it'll do 10 colors times 10 classes. So I'll get 100 rows. I don't actually know what the number is for these guys here, but for painting a picture, and throw this column on. And let's see what this looks like when we actually run it. And trust me, the results are correct for the... So let's run that. F5. Cool. So I'm going to go to the results first. So believe it or not, these will be the correct numbers from that larger intermediary table. How many storage engine events have we made? 2, 3, just 1. Okay. You're saying, well, there's 9. There's only one that touches the fact table. These other ones all have a duration and CPU of pretty much instant. They're just lookups. They're in memory, go figure something out very quickly. The one I care about is the one that goes out to the source. It's labeled here in the second column called SQL. That's the one that's fired out a statement to the data source. And what does that look like? If we click on that and zoom in, again, for those of you that recognize T-SQL, what it's saying is I want you to create an intermediary table that's grouped by brand, class, and color. So it's going to have as many rows as there are permutations in there. And inside that intermediary table, go and figure out for every row, what's the sum of sales amount for each one of those unique combinations? What's the sum of sales quantity for each of those unique combinations? And I think possibly sometimes it tells us how many rows it gave to us. I'm going to copy and paste this into SSMS and run it. And this is going to tell me control all, control paste, no, control all delete, control paste, execute. Okay, 294 rows. That's actually still quite tiny. And that's pretty good because the actual underlying fact table, again, could be hundreds of millions or even billions of rows. So there's a question here at the front.
Can I just ask a dumb question? Without DAX Studio, you can't see those server timings and SQL queries that's been fired off.
Okay.
Power BI desktop, can you?
So the question from the audience, for the purpose of people online in the recording, without DAX Studio, can you see those server timings? Yes, you can. You can use other tools like SSMS that I'm using here to run my queries. You can start up a profiler trace. And you can run a profiler trace against it, but the profiler trace won't give it to you in a nice, neat format like DAX Studio does that condenses it into a very quick, easy way to digest. But it's not the only way you can get it. And anything that can use an AS client library, and there are many tools, PowerShell, Fabric notebooks, they can start a trace. If you define your events and capture those, run your query, then you can derive exactly the same information. However, if you're serious about writing DAX, then it's hard to go past DAX Studio and just being able to quickly get to the chase, especially when you're doing this kind of diagnostics and performance tuning. So, and it's actually an Australian product. The main contributor for DAX Studio is Darren Gosbill, a colleague of mine who lives down in Melbourne. So he's going to be here in Brisbane this weekend for SQL Saturday, possibly talking about DAX Studio. So it's a homegrown product, and I love it. So yeah, so my intermediary table that I crafted using this more complicated pattern allows me to minimize it down to one storage engine scan. And I'm not kidding. A very common engagement that I get called into will be, yeah, my matrix is slow. Let's have a look at the server timings. I've got over 140 storage engine scans because their calculations are a lot more complicated than just sum of sales and sum of quantity. Okay, let's apply this approach and pattern across your measures for that visual, and let's see how we can go. And I usually get it down to one call. And I'm going to give you an example now of what that might look like. I'm conscious of time. Great question, by the way. So I do have 2 Power BI reports. There's one here, which is my before. And this is the, hey, someone comes and taps me on the shoulder and says, you know, I've got a slow report. Can you help me optimize this? So let's do that here today to give you a kind of an insight of perhaps how I might help customers. So my slow report's over here on this other tab. So I will go turn on my optimize on the ribbon. I'm in here in Power BI desktop, and I'll find performance analyzer and I'll start recording, because this is going to tell me when I click on the other page, when they load, which is the slowest visual on the page. So we're going to load it now, and hopefully it's not cached. Doesn't appear to be. So I've got a little spinny here that eventually, after about 20 seconds or so, is going to render a visual, render a matrix. And there's a lot going on with this matrix. I'm not even going to attempt to try and make it look like an attractive, pretty report, but we've got a filter on the page that allows the end user to pick a month, say May 2008. This is Contoso data. They can pick what brand they want to run over. Multiple brands, no brands, all brands. In my matrix, which eventually loaded, and it took 34 seconds, I've got 5 measures. And for each measure, I do a comparison for that measure. So I've got sales quantity, count of sales, return amount, and return quantity. For each of those visuals, each of those measures, sorry, I also want to have the ability to pick a comparison period. Like I want my matrix to show either, and this is user selectable, what was the previous month? So May would be compared to April, or the same month last year. So May 2007, for example. So there's dynamic stuff. And on top of that, in my filter panel, I also say, I only want to see the top 5 performing stores. So somewhere in this filter panel, I probably have a measure as a filter saying for my matrix, don't give me every single possible store, just the top 5 stores. And that can actually give you a performance hit as well. It can actually cause it to do more work. So this is my big S500 customer X. They want me to speed up this matrix. So I'll go, okay, we captured it on the performance analyzer. Let's copy the query and let's take it over to DAX Studio. Now, if I run it in DAX Studio, it should just take 34 seconds. Might be a little bit quicker because the other visuals aren't rendering, for example, but I'm going to save you that time. But usually the first thing I look at before Fusion is the data model. And in this case, the data model is doing probably a couple of naughty things. It's looking like best practice star schema, but the relationships have got this arrow pointing in 2 directions. So every single relationship in this model is bidirectional. And it's not uncommon to see more with this. There are genuine use cases where you might need a relationship to be bidirectional, but there are many times where I see it used and it's just not needed. So if you are using it, a bidirectional relationship, double check whether you need it at all. The other thing is my fact table is in direct query mode, and you can see that it's in direct query mode because it's got this blue line on the top. None of my other tables have got this blue line. And so I need to go and figure out what's the storage mode for those tables. And they'll all share the same identifier across the top of the table in this view. And if I go to the properties for one of these tables, I can see that it's using import mode. So all of these other tables, the DIM tables, are using import mode. And when you're using direct query, they should really be using dual mode, not import, because dual allows the table to run in both direct query and import at the same time. Why would you want to do that? Okay, so import, if my query only touches the geography table and nothing else, then it will use the import version of the table because it'll be quick. Like, how do I populate the unique values of a slicer? When I'm rendering the page, I want that to be very fast. However, if I'm running a query like sum sales amount from fact name grouped by a column over in product, so yeah, sum sales and fact sale, sum my sales in my fact sales direct query table, but group or filter by something in my product table, I don't want to use the import table because they're separate. That would guarantee I have to do 2 passes. Whereas if they're both in the same data island, if they're both in direct query mode, I can construct a DQ statement like the ones we've been looking at here that go from fact table in it or left join off to my table, and it can do it in one hit. So the very first thing, all I'm going to do to this table is this model is change the relationships to be one-to-many and standard, and set my 5 DIM tables to be dual. But I should really capture that DAX actually. I'm going to capture that DAX, put it into query 1, and it's here, and paste it in. And if I've got my server timings going, I'll just make sure I'm connected actually. Expand ribbon, connect to my before, because we want to look at what the server timings looks like, that we can see a bit of a clue from last time I ran it. So while that's running, we can actually start talking about it here, because the numbers should be quite similar. The total elapsed time is going to be around 30 seconds. But that's not the end of the story. That's just how long it actually took from where to go. Underneath the covers, it was doing so much work that it consumed a bunch of cores and chewed up a lot more server time. And this is what goes into your premium capacity compute. So if you've got a big number here, that's going to show up in your capacity metrics report and start potentially throttling things out. Now remember those queries we were running before that had 1 storage engine scan? This one's got 339. So there's red flags and alarm bells going off there. Not all of them are, and here's my result. What did it actually take? I didn't actually have server timings going, but they're the same. Not all of those storage engine scans are SQL scans. So we can actually sort by maybe duration there, and all my SQL events are at one end. I'll just resort that actually. But there's a lot. There's I'm going to scroll down. There's lots and lots and lots of SQL scans, and if I actually just sort of click on these, believe it or not, there's a lot of repetition, a lot of similarity in these events. It's just we're going back and forward to the store, and it's driving the chef nuts because they have to wait until all the data's back before they can do anything. So can we fuse this down? There's a lot here. I think there's about 60 or 70 SQL statements in here. I'm going to run exactly the same query against the version of the model that we haven't started playing with the DAX yet, just fixing the relationships and just fixing the storage mode. So I'm going to connect to my after model. Cool. And that's connected. I'll turn on my server timings. So we're about 30 seconds, 339 storage engine queries. And maybe it's about 12 or 13 seconds, I think. Here we go. It's finished at 11 seconds. It's just writing up the SE events. We're down from 339 down to 124. So that's already a big jump. And if I sort by duration, because all the SQL ones will be the ones that take time, yes, I'm scanning down. And I am still scanning down quite a lot. I wish I could actually have an index where I could quickly count how many there are. But now we're going to start getting into fusing these together. So query A is the query that we just run. So query B, what we're going to do is this particular table used a calculation group. So how many people have used calculation groups in the DAX model so far? Not too many. They're actually really, really good. What they do is they reduce your ability to make measure sprawl because you can define a common time intelligence type calculation like year to date or month to date or running total for the year. There's a whole bunch that you might do, period comparisons, etc. And you don't have to, like if you have 10 measures and 10 time intelligence periods, you don't want to end up with 100 measures. Calculation groups will help keep that down. However, unfortunately, calculation groups block Fusion. We haven't finished parts of the engine that enable Fusion to kick in. So the very first DAX that I'm going to run here is going to use an alternative approach to calculation groups. And what that is going back in time before calculation groups existed and just having a disconnected table. In this case, what is our calculation group actually doing and what does it look like? So over here, I've got a table called, if I find it in my model, this is an older version of Power BI. Just have to remind myself, I'm going to open up Tabular Editor, which is another modeling tool you might want to consider if you're doing more advanced modeling. And this is going to remind me which of these tables is the calculation group, because one of them's the before and one of them's the after. In fact, I can probably figure it out from the query because the DAX query in A is doing a period comp. All right, so let's have a look at the period comp table in the model. What does the data look like? So period comp, no, must be time intel. It is time intel. Okay, so my calculation group has only got 3 entries. If I drag it over to the screen that's been shared. So there's a month to compare, a selected measure, and a this year versus last year. So what I do is I introduce the same sort of table and use that instead and bake the management of what to select inside the measure. So down here in the DAX calculation, this is the core calculation that the visual needs. What it's saying for my matrix is I want to group by continent and store. So we saw that on the row header. Now for that, I want to run, you know, a measure, matrix measures. Okay, so that's the thing that's replacing the calculation group. And then I've got my measures down here, the current month, the comparable month, and the percentage difference between them for all 5 measures. If we come up here, okay, so I've actually got them built into the model. I'm going to run this because just for time to show you what the effect this has on the storage engine with the server timings, run it. And then we'll have a look at a couple of the measures. Okay, cool. So 11 seconds came down to 1.6 seconds. Trust me, we have the correct results. And the server timings is we're now down to 13 total storage engine scans, which if I sort by duration, we've got 1, 2, 3, 4, 5 storage engine scans that touch the fact table. Remember, we started with about 60 or 70, and we're producing exactly the same result here. Even these numbers here, the total amount of time taken is a fraction of the 28, 30 seconds we started. Only 3 seconds of server compute. It's well worth doing. So let's have a look at what some of these measures look like. So in the after, they are called B measures. Yep. Okay, so the current month is not doing my SumX trick. Remember the horizontal fusion trick? So this is just doing the classic, I want to, my measure is sales. Where is my sales measure? Excuse me. Version A. So sales is just sum of sales. Quantity is sum of quantity. And in this first iteration, what I'm doing is saying, don't use the calculation group. Go and look up a disconnected table to figure out what we need to draw into the visual. Because remember on the matrix visual, we represent 5, we let the user select 5 measures. And then for each column, it goes and figures out what calculation to use. And this is all nice and simple. And there's not a lot to it. My comparison month just really calls my core measure with an offset. And then my percentage difference is not complicated at all as well. So that's actually pretty straightforward, but we've still got 5 storage engine scans. Now that doesn't look too bad in this example with this size data, but again, when you start putting this in an enterprise scale, it can really start blowing up on you. So the next approach is to, I go back to DAX Studio, because I'm doing 3 layers here. That was the first of 3 layers. And the first layer said, we're going to use a measure table instead of a calc group. We're still using the classic date table, and we're not using the SumX approach to craft that intermediary table. So the next query is going to get us down to 1 storage engine scan. We're using a date table, not a time intelligence table, which is another thing. But here we're introducing the SumX pattern. And when I connect to the the same model, the after, and I turn on my server timings, this one here, I have implemented that trick to allow Fusion to kick in. And if we run this, remember the last query was only 1.3 seconds and was 5 fact table scans. This one's already taking 7, 8, 9, 10 seconds. So we're going backwards here. But we are down to 1 storage engine scan. Because if I sort by duration, we've only got 1. Now 1 surely is better, right? 1's better than 5, but clearly it's not. It only took 2.5 seconds, or 2.2 seconds. Where did the other 9 seconds go? What was it actually doing? Now, the reason why this is slow is because the intermediary table we asked it to get is now too big. If I take this query, jump it over to this one query into SSMS to see what that intermediary table actually looks like in terms of number of rows, 10,000 rows. And it's got to post-process that quite a bit with the matrix. It's got to actually run a couple of loops and loops inside loops over that. It can extrapolate out. So how do we fix this? Let's have a look at the query a little more closely. What's it doing? Regular fusion is kicking in. That's good. We've got all the 5 metrics in the select statement. We're expecting that. What are we grouping by? We're grouping by continent, first dated month, and store key. So what's the permutation? Remember 10 colors and 10 classes, 100. Well, maybe this is 10 times 10 times 10. Or 10 times 10 times 100, getting us to 10,000, something like that. I've been up since 2 o'clock this morning, so maths is not my strong point. We're joining the store table because we're filtering there. We're joining the geography table, we're filtering there. We're joining the dim date table and the product table, etc. But the thing is, in the result set, we're getting a value for every single date. And we don't care about every single date. We actually only want 1 month of data and a comparable month. So we don't need what might be 5 years of data. We only really want to have this statement run to give us less to post-process. So we need to influence the where clause. We need to inject something into the where clause that doesn't change the grouping, but it reduces the amount of rows that come back. And I've got a technique on my website, my blog, that talks about time intelligence, row-based time intelligence. And I've implemented that on the last approach and last query. And again, to save time, we'll jump to it and have a look. I'm just going to double check what else we did in 3. No, nothing else. That's exactly what happened in D. So if we go here and here, connect to the after one. So this is the last attempt. We're now using a time intelligence table. So this is a dedicated physical table in the model that's joined, that we're going to put a slicer over. And because it's joined, that is going to influence and turn up in the where clause, which is what we want. We're going to see fusing of the where clause. And let's actually now run this. I've got server timings on. No, I don't. So it's exactly the same core query. And if we run this, okay, that was pretty quick. Was it 1.3 seconds? 1.6 seconds. Okay, but the server compute was only a second. The storage engine scans, we only have a single fact table scan because that's the only SQL one. If we have a look at this, this is practically identical to the last one. Regular fusion's kicking in. We've got the same grouping by cardinality. We have the same joins, but this is the difference. In our where clause, we're now limiting our intermediary table to only be for May 2008, April 2008, and May 2007. And if I go change the date, that'll actually influence, that'll come through to the where clause as well. So this is where you need to also go in and not just create the intermediary table approach, but make sure it's not exploding out unnecessarily and using techniques like a physical table in your slicer, using a time intelligence table. So let's have a look at some of these SumX measures in practice. So if we go to my after, and I can make these PBIX files available. So in version D, we'll skip to that. My core measure now has my SumX approach. So it has 5 blocks of them. One where we do sales, and then we have exactly the same block, but the only difference is we have quantity. A third block, identical, calls that measure. And this is a measure where it is just doing one line, sum of sales, sum of quantity, sum of whatever, but it's wrapped up in this iterator pattern that's saying, when you do this, can you please give it to me? Not just actually for all stores, but all stores and continents. Now I've got nested SumXs here because some of my dimension columns that I need to group by exist in different tables. It looks a bit weird, but believe me, this works perfectly nicely. In fact, I've actually got 3 nested SumXs here. And these control, what I have highlighted here, control what the storage engine does. They shape the intermediary table that we want to get. And here, the logic afterwards, that's how we post-process in the formula engine. So once we've got our, and it wouldn't be a 10,000 row table. If I actually go and take that table from, with the where clause, back to SSMS, remember the first intermediary table was 10,600 rows. This one is 872 rows. So now we're only post-processing over 872 rows. And this measure, remember at the start I said less DAX is good DAX. And we've got a 116 lines formatted of DAX here. Now, good news, there is a feature coming to Power BI later this year, which is going to give us the ability to optimize the layout of this DAX. So I would be able to do this using far fewer lines of code. I would still be applying the same pattern, but I would do it once. I would say, let's just define this in one place, but then have the ability to just drop that in a clever way. So that's coming. So that's going to simplify it a little bit. And then that's it. And then my current month and my comparable month and my comparison, they're not really complicated. My only really complicated measure is here, and it's just the same pattern pasted over and over again. And hopefully you kind of get what I mean, that it's attempting to just be smart, make one trip to the store, get one basket of goods, come back. It's not a very big basket. We didn't get more than we needed, or we didn't get too much more than we needed. And it's much easier to actually get that delicious cake running really quickly. And we can factory process these out very, very quickly. So I'm going to go to my slides and remind myself we're only up to slide 2. What's the time? Don't worry, that's it. So here's my matrix. And actually also part of that, a little bit embedded in those calculations, was handling the top 5 as well, because that can introduce unnecessarily storage engine calls. So there's a way to solve that in these PBIX files. So what I'm going to do is share both of these plus the DAX queries with Craig after the session if you want to go have a look through, if you want help getting to sleep. So what do we do? Busy matrix visual in Power BI, it's super slow. That matrix had 5 core measures, but when you had the comparison and the deltas, there's 15 things going on. We were grouping by store. We were giving the user the ability to control dynamically how to filter these things. There was a calculation group at play with the time intelligence initially. There was the top 5 thing that we just talked about. Here's the before model. We fixed the relationships. We went through the DAX changes. We used a measure table in place of the calc group initially. Then we introduced the X pattern, which took us backwards. But then we crafted that X pattern by putting a where clause on it by using a time intelligence table, and we got the best result. So, summary. What are takeaways? Use appropriate tools. DAX Studio is a fantastic tool. I would find things very hard to use without it. In fact, I had someone contact me on Monday this week for exactly the same thing. I actually sent him a link to a video that I've done this elsewhere. It was slow visual. It was taking 20 seconds to complete, 200 seconds of server time. And on Monday morning, this is over in North America, it was maxing out the capacity. We'd loaned them a P4 and it was just coping. We took away the loan off them and they were down to a P3 and it was maxing out and they were getting angry, and said, okay, let's have a look at it. I see the problem. In their case, we had, I forget the number, it was like 40 fact table scans. We got it down to 2. And that was deliberate because there were very, very subtle differences in the filters that they needed to do. And we didn't want to blow out the cardinality as well. If we had combined it to 1, we would have gone back to this sort of middle stage. It was actually faster to do with 2 rather than 1 in that particular case. And we've got their results down to what we've similar seen. So they're going to implement this week, and we're hoping to get them down to a P2 next month. So next time I'm over there in North America, I'm sure I'm going to be able to get a coffee or a beer off that team. It's good to understand what regular fusion and horizontal fusion are actually there for and what they're trying to do. Trying to reduce the number of trips to the storage engine. I do recommend considering a time intelligence table. That's the thing at the end that really got us over the line. And that the whole point of that is gives us the ability to inject a where clause to minimize the dates down to just what we want to see. And I have a whole blog on exactly how that works. It's about 4 years old, so it's not brand new, but it's fast and it works. And part of it uses a BiDi table, funnily enough, and will tell you most of the time, best practice, avoid them. But that's a good case and a genuine use where you want to use it. There's another couple of things like at the moment, if you use switch true with else clauses, we don't fuse sometimes. So there's some patterns that I've applied here tonight that will use switch correctly without an else. It's all to do with eager and non-eager building of our query plan. We use variables even today. It's not unusual to see a measure get called 5 or 6 times in a measure, rather than just call it once and assign it to a variable and then do all your maths on that variable, for example. Because even that, if you're not using Fusion, that just blows the storage engine scans out the water, increases your compute, and it's going to cost you money. Which sounds weird. I'm trying to save you money. So, well, yeah, our sales team weren't probably that impressed with me saying, oh, we're going to get you down to this P2. Should you apply all these techniques all the time? No way. No, absolutely not. You know, not even every single measure on a visual. Save it for that really important one that's going to get busy, that is actually slow, that is over a lot of data. And it's the matrix ones that win, because they are quite often different flavors of hitting the same fact table, whether it's pairing comparisons or just summing or aggregating slightly different columns. But when you do need it, absolutely. Yeah, performance versus flexibility. So the problem is you get good performance with this technique, but you do end up with more DAX, and it's hard to explain. It's hard to maintain. You kind of figure it out when you're working on it, but come back 2 months later. How does this all work again? So maybe make lots of good comments in there, or save this video, because it is harder to maintain. And you do have to be careful. If someone comes along and adds a new column into your matrix, it might not now fit that SumX pattern that you've crafted, and all of a sudden it's going slowly again because we've fallen back and we're not fusing and we're doing lots and lots of mini steps, as opposed to what I've shown you here. And while I have used direct query in this example, that was just to make it easy to spot when we were doing a fact table scan. Exactly the same principles would apply for import and direct lake too. So there's no difference. So we're gunning for Fusion on those really critical, important visuals. So thank you. We've got plenty of time for questions, I think. I don't know if we've got any online.
Yeah, we got a few. So just when you were talking about the difference between import and dual mode, that sort of sparked a bit of a side conversation online.
Okay, cool.
And people were by and large answering each other, hence I didn't interrupt you. But there's a few that have gone unanswered. So the first one from David is, does direct lake use less fabric capacity than having the Power BI semantic model in import mode? If you could repeat.
Yeah, no, that's fair enough. So the question is, with direct lake, which is a brand new storage mode that you only get in Fabric, does it use less overall compute than import mode? It can be both ways. It's possible for direct lake to be used more compute potentially than import. You know, import might be over a very ugly model and doing lots and lots of Power Query, and if you're running your refreshes every 10 minutes, then it's going to generate a huge amount of compute just on the refresh, for example. And you'll be surprised, of your overall compute usage, it's likely that 80% of your compute is probably coming from your refreshes. So you need to make sure your refreshes are optimized. Direct Lake's not quite the same as import because it cheats in that the data is already processed in a way that direct query doesn't have to do much to get it in. So for compute in terms of getting data into the model, if it's like for like type of data sets, direct lake should use a lot less. But if you've got spectacularly high cardinality columns over billion row tables, then maybe import might be better because you can do incremental refresh, partition management. It quickly becomes a very murky question. The data model sizes should be about the same. Direct lake gives you the ability to page in columns and evict columns, so you can probably do more with less with direct lake. But the query side of things should be much of a muchness. So when it comes time to actually compare a similar import and direct lake model and just look at the compute on queries only, again, it depends. I can actually get a direct lake query to smoke an import query because of what I can do upstream in the lakehouse to get the data in a certain way to fit queries so that my direct lake query can use a fraction of the compute that an import equivalent might do. But then if I work hard, I can probably do the same thing in import. So unfortunately, that particular question just comes down to it depends. So it can be both in the refresh side of things and in the query speed, but it probably shouldn't matter too much. If it's important and critical to you, create a parallel POC and just look for yourself on your data with the way you like to get data in, on the frequency you like to get data in, run the queries you like to run against it, and then just, you should easily be able to do like for like, because you can see in the capacity metrics app how much compute each semantic model is consuming or generating, so you'll quickly know which is better. So hopefully that answers your question.
Yeah, David has come back and said thank you. Anybody else in the room?
But if you have, say, 3 fact tables, do you achieve the same fusion as well?
Great question. So for the purpose of people online, if you've got 3 fact tables, can you get fusion? So no, you can only fuse queries to the same fact table. So here in my model, it was simple. I only had 1 fact table. But yes, if I had another fact table, and in my matrix, I had a bunch of measures that talk to 1 fact table and some measures that talk to the other, and even combined, then the least we can get it down to is as many storage engine scans as there are fact tables. So and there are plenty of good cases when you would have multiple fact tables. I had one in the example I just told you about. Actually, there were 2, but one of those fact tables was so tiny it just barely showed up. It was a blip, so we didn't even care about that. The other one was big. So
Question online, 100% understand it, but I'll read it out. There was a question about whether DAX will be still required in the future, and what Rodrigo is saying is, as a future strategy for developing fabric semantic models using lake houses and warehouses as direct lake, as they both use SQL and a native DAX won't be necessary as it is for Power BI local memory-based engine.
okay, so I get the challenge. I mean, I get the question, and this is actually not a new question. So why do we actually even need DAX? So DAX is especially good for that dynamic runtime measure-based approach. So when the user loads the report, they want to change some slices, and that information is really only visible at DAX time. And a really common type of measure that we like to do on our reports are period comparisons, running totals, child-to-parent relationships. And they're really hard to do in SQL. It's not straightforward. SQL wasn't really designed for that kind of work. So they work quite nicely together. So DAX can talk to SQL the way we've been doing tonight to get what it needs, to then actually using the nice simplistic syntax of DAX and not the SumX pattern that I've been talking about. But if I was to write DAX to do time intelligence and period comparisons, running totals, and these types of things, I'm not going to have to do terribly much. Whereas if I was to do the equivalent in SQL, it's a lot more complicated. It's doable, but it's not really designed to do that metrics. And that's the gap with these lake houses and other things. You can do them as ad hoc one-off. There's no problem. But if you try and package that into a report where you want people to be able to, click on a wedge in a pie chart and other visuals react and shift, that's DAX is very, very optimized for that kind of work. So I don't think DAX is necessarily going to go away. DAX will always be there underneath the covers, but what you'll probably find is more and more using things like quick measures, Q&A, the new co-pilots as it comes up. There'll be less need for you to necessarily learn and become an expert. You can sort of say, hey, I just want you to take my data and summarize it, do period comparisons, whatever, and let it write the DAX for you. And you can go on and tweak it if you like. But I think, yeah, I don't think SQL is anything closely suited to be able to do BI analytic reporting type functions that that DAX can do very effortlessly. But they work together nicely together. They can, as you saw tonight, in direct query mode, they can complement each other well. So hopefully that answers your question. So, And I mean, you can run in direct query mode, so DAX doesn't have to have any data locally inside its own import tables. It can translate on the fly to a bunch of SQL statements, go get what it needs, and then post-process, finish off and go and figure out what it needs to do to render the matrix or the line chart or the bar chart or tooltips, etc. So.
They discussed it online and had an answer, but
Okay.
nothing's.
Find it.
Yeah, so I've got on the screen here, this is a composite model. So you'll notice at the bottom, my fact table with the stars around it, which is on the many side of the relationships, it's got the solid bar that's telling me it's in direct query mode. But these other tables have got this dash. It's a bit of white, bit of blue. Now white is defaults to import, blue is direct query. So it's sort of, these dimension tables are operating as both an import and a direct query table at the same time. So if the query just needs to touch the table only, give me the unique values of the month column so I can populate a slicer, then I'll use the import table. It makes sense. I don't need to send a query to the direct query source to get that. I can just get it quickly here. But if I am doing a sum of sales over my fact table grouped by month, these are in different, the import and the direct query tables are in different places. I would much rather send a query to the fact sales table that had the inner join. And in that case, it sort of treats the dimension table as if it was direct query. And it knows when to use that and is smart about it. And it allows us to push the question to the source in a less steps. And as you saw with more advanced techniques, we can do very, very complicated things in one trip to the one SQL statement. Why wouldn't you have everything in dual mode? Well, it's probably, a lot of people would just go 100% import. Okay, so the question would be, would you go 100% direct query? Probably not. So if you're going to be, if your fact table's an import, just go everything in import. But if your fact table's too big or there's real-time reasons to have it in direct query mode, then you could have all of these other tables in direct query mode too. But that means when you load your report, your slices will just be a bit sluggish. They will work. You'll get the correct result. But if you have these in dual mode, your slices will be instant. And then your main visuals that are actually doing work over your direct query table, that will get pushed down and use the same model definition, the same columns, the same filters. So if your fact table is in direct query mode, then I would recommend your dimension tables be in dual. So hopefully you're getting that online too. Sorry, I wasn't repeating the question that well, but we have one over here.
Yeah. Why is bi-directional relationships between tokens? Is it like a performance thing that it's recommended against?
Okay, so the question is, with bi-directional relationships, you hear that it can be a performance problem. Okay, there is a genuine use case when you need it. The thing about bi-directional relationships is, it allows things to go two ways. So you can have a filter on a table down here that affects rows up here, as opposed to the other way around. Sorry, did I repeat the question? I did repeat the question.
Yeah.
Now, there are some cases where you do need that. But unfortunately, if you just have it on by default, when we generate our query plan, so your visual loads, the DAX query gets sent to the engine, and the engine has to create a plan, has to go, right, how am I going to bake this cake? How many trips to the storage engine am I going to make? With the bi-directional at play, I have to be more conservative. So I probably have to go, maybe I can do this in 2 trips, but to be sure I get the right results, I think I'm going to have to do 10 trips just to be sure. Okay. And with bi-directional relationships at play, unfortunately, what that can do is influence the query plan to be more conservative and end up taking longer. Whereas if you genuinely don't need it and you set the relationship to be just a strong relationship, standard one-to-many, with a filter going one way, then when we're generating that query plan, we can go, okay, we can take some shortcuts here. We know we can only take 1 or 2 trips to the storage engine and get what we need because we know what's going on. We don't have to be so conservative, and we know we can still deliver the accurate results. because unfortunately BiDi relationships can actually flow and through multiple chains of tables,
like,
and
circular.
we'll never let you do a circular one. But you know, if you've got lots and lots of tables and they're all BiDi, then if you've got filters there and group bys over here and sums over here, then it's going to be harder for the query plan to factor in all the weird edge cases that might come to play. And that's why if you genuinely need it, great, it can actually be useful. And my time intelligence approach does have that, I think. It's either that or many-to-many. I'm just going to remind myself. It's many-to-many, it's single dir. Yep, many-to-many, which is similar sort of challenges. I'm using many-to-many here because I know the time intelligence table is always filtering down heavily to a single cardinality or 2 or 3 rows. Many-to-many is a problem when both sides are filtered with high cardinality, i.e. just the user hasn't needed to filter it down. You've got a million unique keys over here and a million unique keys over here, and they have to go and sort through all that, and you'll be there. You'll be hitting errors. So hopefully that answers your question about the BiDi.
Yeah, I've got a database about 60 tables in it. While developing it, wasn't sure how I need to connect everything, so I just made everything.
Well, my example tonight,
directional, but I can then see through this.
Yeah,
it can get really confused.
My example tonight, my very, very first example, my before, I deliberately had all of the relationships BiDi. Yeah. They were still one-to-many, and there was 339 storage engine scans, even internal little scans, you know.
Yeah.
And all I did was change that and set the columns to dual. Okay, there's 2 things going on. Maybe I should have shown one where we only touch the relationships, but I suspect the query plan for the fix of the relationships would be a big jump, but still produce the same result. So how are we going for time? Quarter past.
Yeah, we're doing well.
There was a question here. I think you had a second one.
It's just showing that last measure with the necessity array.
Sure, absolutely.
I'm not sure if from here if I saw times or moment.
Okay.
Oh yeah, so that part where you have all dim geography, constant and sale, then would you mind explaining that second bit, that times store key in my stores? What is that? How you do the where condition?
Okay. So the question is, what is the reason to have this block of code here in the pattern? And there are 2 parts to this. The first part is crafting the shape of the intermediary table. And the second box I've just drawn here at the top, that's influencing the storage engine, telling it what the cardinality, the grouping of the intermediary table we need it to be. So it's going to have 1, 2, 3, 4, 5 columns at least. And we're going to get every permutation of however many unique values are in that. And that's our intermediary table. And that's what the storage engine does. It gets that back. And I think we copied and pasted and ran it in SSMS. And in that intermediary table, we actually add an aggregate, which is sum of sales. So the box that you're asking about is what's the purpose here? Now, this is the post-processing in the formula engine that helps the measure that we're calling figure out what needs to go in every unique cell of the matrix. Sounds like a movie, but when I go to version D here, how do we know that this cell here should have that number in it? This is a combination of rows that belong to this store, this month, this brand, and possibly some whatever things. Now, how does that differentiate to this one down here? This belongs to a slightly different store. I've got my arrow around the wrong way. Okay, so we jump back to DAX Studio. No, it was in here. The measure. I'll zoom in. So what we do at the start of the measure is when it's called pretty much per cell. If you can imagine, every single cell in my matrix is making a call to the measure, like a function call. And that cell is saying, I belong to store A and this month. And we capture that up here in some variables. And the next cell over is going to have a slightly different value stored in here. And these are what get applied by the formula engine, because the intermediary table is actually still quite big here. It's 800 rows. How do we figure out which of those rows we need to use to arrive at the number we need to present for the cell that the measure belongs to? And this here is the instruction to the formula engine how to post-process that intermediary table. So each one of these variables belongs to up here, and one of them is store. So remember I highlighted 2 stores. So in the measure that had the first number, we're going to have the store that belongs to the first store. And then the other measure I had the backward arrow to, that's going to have a slightly different value in here to get its one single scalar number. And so therefore here, that's going to have a slightly different value. It could be a group of values as well. You know, in this case, it's only ever going to be one value in the way I've used it. So it's the, it allows us, once we've got the ingredients back from the supermarket, it allows us to then go, all right, now which bit do we need to use? Because we've got 12 eggs, we only need that egg for this thing, or that's probably not a great analogy, but the purpose of this second block is for the formula engine to post-process the intermediary table that the storage engine gets for us. So it's what the chef's doing.
It's quite clever because actually, first time I read it, looks like you're multiplying sales by
No.
and no,
It's in a bracket. It's this is a big Boolean. So these all kind of turn out to be just a true or false. So what we're really doing is, because an X function in DAX is an iterator, we're just going to go, once we've got our 800 rows back from the store, we're just going to iterate down through all 800 rows, and then only the rows where all of these values are true will get returned for that cell. And then the cell that was a little bit below post-processes over the same 800 rows, but we'll use slightly different rows. And this is that Boolean that tells you in the intermediary table which row to be used for that particular cell of the visual. It's invisible to you. You know, we're not actually having to do much. So hopefully that makes sense. Cool. All right. So thank you all for coming tonight. I know this was an advanced topic. Like I said, you don't have to remember any of it at all. It's recorded. Hopefully it gives you an insight at least to, if you are doing some diagnostics and performance tuning, you know, how you can connect with DAX Studio, you know, how you can think about DAX, how you can look at the server timings. But otherwise, I definitely want to thank the hosts, Randstad, for the fantastic environment, and Craig and Gilbert for organising everything, and the other sponsors, etc. The pizza's awesome. I'm not sure how many is left, but I'm going to stick around. I can more than happy to answer more questions if there's more pizza. But otherwise, thank you very much.
Thank you, Phil.
No worries. Yeah, you want to stop sharing or Alt Tab to...
Right, thanks everyone for attending. So we're actually going to have a busy period because we've been sort of landing some speakers on a regular basis. So our next meeting is going to be on the 1st of August, so just around the corner. And then we're going to have another one on the 21st of August. So we're really cramming them in these next 2 months. So just keep your eyes open on Meetup. We'll publish the next one within the next couple of days. And yeah, and thank you again to Phil. I know it was an advanced topic, but wow, I learned a lot today. So thank you very much for that, Phil. All right. Thank you all, and we'll see you at the next meeting.
Stop sharing, recording, and